invite Professor Scientist Dr. Manzoor Ahmed ji to come over the dais and be with you. Thank you, sir. Welcome.
A very good afternoon to all the dignitaries and participants of this course. Today I'm going to deliver a talk on green IT. The main intent is to expose you towards the aftermath of technological devices. So what exactly is green IT? Sometimes we call it as green computing also. It's basically having an environment-friendly approach from technology procurement to disposal to enable the sustainable business practice. What it exactly means is that we need to be environment conscious when we actually buy IT devices, and then when buying we have to think of the disposal of those devices when they retire. And finally we need to achieve our business also in this competitive world. Why do we need this green IT? First of all, a lot of energy is often waste. By this what we mean is whenever we use a computer, we sometimes keep on we keep on the computer and leave the desk, or sometimes keep screensavers on, which keep on using the power and finally wasting the energy. Another thing is we keep on printing the drafts, sometimes our emails, and sometimes we make drafts of notes, which again is wasteful of paper. So paper again is taking lots of our plants, trees to get manufactured, and we actually need to save those trees in order to reduce printing. Though being in this computer society, we still keep on using more and more paper. The third one is pollution. The computers that are manufactured use lots of toxic chemical substances, which include lead, mercury, plastic, cadmium, many other chemical substances for this manufacture. So finally, then when it is packaged, it again uses plastic and foam, which is for its packaging, and then cardboards for final destination. And when we actually receive the goods, we then have to think about the disposal of the packaging which comes along with that computer. So it again is a form of pollution. Then finally, toxicity. The problem with this is that these chemical substances with which these computer devices or electronic devices are manufactured contain toxic substances which finally go in the form of food chains into land, in our food chains through landfills. Finally, when they retire, they are put in landfills. They go into a form which finally go into the food chain in the form of fishes which may swim in the water in which comes from those landfills, and finally they make they affect the humans in the human systems, which may involve our nervous system or other body. And finally, this impact is that it's very harmful for human beings. So we have to be aware that we have to be green.
So just a minute. Yes.
This is the global green 4R mantra, which says that first of all, on our individual levels, we need to reduce the usage of energy and improve efficiency. We need to reuse the things. So for example, if it is paper, let us think of reusing the paper if it is possible. The third one is refurbish. Say for example, if you are using a computer and it gets obsolete, if you can refurbish some of the parts, probably we may use it again. And the fourth one is recycle. If there is no alternative, then you can send the product for recycling. Some of the parts may get recycled and be again used into manufacturing. These are the goals of green IT. One is, let us reduce the use of hazardous materials. and try to increase it as much as possible. Maximize the energy efficiency. So if we are using power, say for example, in a data center where we have lots of servers, you can maximize the energy by shutting down some of the making the server sleep for some time when they are not used during the night time. Or if you are using a printer, you'd prefer a network printer rather than going for a individual PC. And if it's a power supply where you have some of the losses of power, you can reduce your power supplies into multiple units where the power supply may be used as per the load that is required, and simultaneously reduce the energy losses. And the third one is promote recyclability or biodegradability. In this, what we suggest is, let us use those materials which are biodegradable, and let us see that the products, the computers which are made are recycled. Say some of the companies, for example, HP uses the material for its ink cartridges which can be recycled, and some of the companies even pay postage along with the cartons for taking your cartridges and then again recycling them. So their postage, prepaid postage along with the carton to take the used cartridges for recycling. So we have to promote that. The problem, this is the general, if we are climate savvy. Okay. So the problem is manifolds. One is rising one is rising energy demand. So all of us are using more and more computers. So the number of computer users are increasing day by day. So the amount of energy which we need is also being the amount of energy we need is also having a increasing demand. We are not able to cater the amount of energy that is required by those users. So we have to find an alternative way and find a solution to this problem. The next one is, every computer has some age. Normally, earlier it was 5 years for a computer, but the amount of advancement that's being done in the development of electronics and computer science has made the life to reduce somewhere between 2 to 3 years. After every 3 years, we plan to buy a new computer because of its speed, because of the memory power, and the older computer we need to find some solution to dispose them. So disposal of this e-waste. The next one is management of hazardous toxins. So we need to, the problem is, how do we manage the toxins of which this computers are, of the material of which this computer is made, and then how do we plan to overcome the problems that are going to affect the people who are actually going to recycle it. The third one is the infrastructure, the other one is rising travel and infrastructure cost. The travel costs are increasing. We have to move from one place to another place for work, and when we move for the work, we create pollution in the form of emissions of our exhaust of our cars. Then the infrastructure where real estate, where buildings where we work, these buildings have rising costs. The lighting, the air conditioning of those buildings is again an increasing impact. This is one more problem to our climate, to our greener side of IT. And finally, we don't have a proper regulation in India to control the buying and then disposal of this electronic waste. What it means is, for example, in case of US and other so-called developed nations, they have a proper regulation for even when you buy an electronic product and then when you plan to dispose it. And they even do not encourage the recycling of computers in their country. Instead, they suggests that this should be exported to other countries like China and India and other underdeveloped countries. So we need to be aware about this problem also. We need to have a regulation wherein we can stop the import of this electronic waste from these countries, instead promote the use of the modern technology systems. What are the toxins that are being used in our computers? One of the main chemical element that is being used in computers is the lead. It's used in soldering of PCBs as well as the glass of the CRT. When this lead is disposed, it can affect the human nervous system. It can even affect the kidneys. So we have to be very conscious about the usage of lead and try to reduce it as much as possible. Today we have lead-free soldering available, so we should prefer to have devices where lead is used to the minimum. The next one is mercury. Mercury is another chemical substance which is used in housing, in the printed circuit boards, as well as batteries. Again, when it gets methylated, it goes into, finally this during disposal, it goes into the landfills where it enters the water. Finally, this methylated mercury gets deposited into the living organisms like fish, and this fish finally enters our food chain. So what happens is this mercury finally comes into our human body, and it again affects our nervous systems. It can even affect the brain development. Another toxin, which is cadmium, found in resistors for chips, circuit boards, and semiconductor devices. Since these computers are electronic devices and they use all of these semiconductors, so cadmium, there are some traces of cadmium, which again very badly affecting the human life. The wires which are used in the computers have a flame retardant substance called polybrominated carbons, which actually make it a flame retardant. But the problem with this brominated cables is that they again have a effect on human body when they are disposed. Then there is selenium, then there is chromium, which is used for corrosion protection of steel, and then you have finally cobalt in steel for structure as well as magnetism. So all these toxins actually are very harmful for human body. So we have to be aware about computer systems which actually use minimum of this. So as I told you that there are lead-free solders, or there are computers which use minimum of steel and or minimum of plastic for their manufacture, since plastic also goes into the manufacture of the computer, which is again a harmful substance when it is actually disposed. So we can look on all these elements and buy a computer where all these energy conscious materials have been used. And the solution to this is, let's improve energy efficiency. The energy efficiency, for example, for a normal computer user, we always have different modes of a computer. You can improve the energy by either switching off the computer when you are not using it for, say, a week, if you are going out for a week, or you can even hibernate it, which uses some 2% of the power when you are going out for 2 or 3 days. Or you can even turn your computer to a sleep mode when you are just going out for a night. So for example, if you are using in the evening and tomorrow morning you again use your computer, so you can even take it to sleep mode, which uses just 0.8% of the power. So you can improve this efficiency by switching over to different power management modes of a computer system. You can even reduce the life cycle cost. By reducing the life cycle cost of a product means that you can even sometimes, if you have a computer system, you can upgrade some of the parts of the computer, and finally this actually reduces the amount of electronic waste coming out of the computer, since you retain some parts of the computer, and finally the cost of the product actually comes down and the life cycle increases. And we have to find better ways to cut down electronic waste. One of the better ways is to stop importing the electronic waste from other countries, which is obsolete there and which we treat as a new technology in our country. There are three things which actually make modern IT systems. One is the people, another is the processes, and the third one is the infrastructure which we use. The processes actually are the manufacturing processes used by the IT manufacturers entities. One is a manufacturer and another is a user. The manufacturer manufactures a computer, and even these manufacturers are environment conscious. During the design, they design energy efficient system. They even make these systems environmentally sound. And when they finally manufacture it, they plan to have minimal impact on the environment. So the technology which they use to manufacture a computer system or an IT-enabled device has been planned to produce a minimal impact on the environment while it's manufactured. And as a user, we also need to be conscious about reducing the energy consumption. Say, as I told you, in case of a computer system, we can go into 3 different modes. So that's one way of reducing energy consumption. Similarly, if you switch over to efficient UPS systems, power supply systems, which can reduce the losses of power in terms of heat losses, and then finally use it in an environment sound manner. Some people even suggest that if there is a critical range of temperature in which a computer system should work, let's say that the temperature range is somewhere between 15 degrees to say 25 degrees, let us go up to the extreme. Let's not go to the extreme, but a little lower, because every % of air conditioning reduced actually helps us to improve double the energy consumed by for that air conditioning. So what it means exactly is, so if we go to say 22 degrees of cooling, instead of going to 15, we can actually save some 5 degrees of cooling, for which we may have 10% of energy conservation. Finally, when we use a IT product for its lifetime, we can think of refurbishing it or reusing it. And in refurbishing and reusing, one way is to either donate the computer to some institution which needs it, say for example a school which does not need a high-end machine, or give it in a charity where it can be used, or either you can reuse it, find some other reuse applications, for example for printing work or other work. For recycling, then the alternate is recycling. You can even send a product for recycling. So some countries do not even suggest recycling, because when an IT product is recycled, it emits lots of harmful gases which impact the workers in that recycling plant. So they don't even suggest that recycling is a solution to disposal of electronic waste. So we need to concentrate on something which is safe disposal. So the focus areas are design for sustainability, which have to be done on the part of the manufacturer. They have to design energy conscious devices so that they are energy efficient and have some sort of energy marking by energy agency protection, environment protection agencies like EPR, EPSAT. Then we need to have some software which actually manages power on computers. There are a lot of power management softwares which are given by the computer systems, especially for data centers and even now for part of the operating system, where you can manage the power consumption of a computer depending upon its usage. It may trace the movement of a mouse or a keyboard for some time, seeing that it's not being used, and then it automatically switches over into a specific power saving mode. In the data center design, layout, and localization, see, what the best way even for energy conservation is the design of a data center. Say for example, the airflow that comes into the data center servers and then moves out of the data center servers, and anywhere if there is a hot spot for cooling, even track that and give cooling to the specific parts of those servers. Some companies even have come up with the solution of sending cold air to specific parts. So that's one more solution, not cooling everything in a data center, rather cooling the servers, the parts of the servers which actually need cooling on the specific parts. For this, even cooling companies are coming up with ultra modern technology which involve screw type chillers, where the energy is conserved while generating the cold water for air conditioning those data centers. One other focus area is server virtualization. By virtualization, we mean that there's a server at the back end and multiple clients are connected to it, and all these clients get access to different operating systems from the server. Physically, they are independent units, but logically they have access to a lot of resources. And the advantage is that these small the desktops can have access to bigger resources in a client server model and still generate lesser amount of heat, consume lesser amount of power. One more area where the major focus has to be is disposal and recycling, because as I told you earlier also that every IT product has its own lifespan, whether it's 3 years or 5 years depending upon our usage, but ultimately it retires. And once it retires, we need to find a solution for its disposal. Best way is follow the global green mantra: reuse, refurbish, recycle. And if you are not able to finally dispose, then follow the one more activity is compliance. We need all the IT devices to follow some compliance by the energy protection agencies or the environmental check tools. So there are some tools in other countries which have to be followed before we actually buy the IT product. So with these tools, we actually come to know that how much energy conservation is being done by those devices. So for example, EPA has come with a standard called Energy Star 5.0, which actually says that 85% of the energy is utilized by a device having a Energy Star 5.0 mark. And it may also increase depending upon our power management techniques. Also, we need to have some matrices, some assessments, and some methodology to strictly adhere to those energy conservation principles, which can help us to measure how much energy is conserved and whether we are getting the exact efficiency with the simultaneously conserving the energy. Finally, what is at risk? And the risks involved are huge because human life is involved, and we need to mitigate those risks depending upon both the manufacturing process as well as the usage of that product. Finally, how much renewable energy are we using? whether it's wind energy, whether it's solar energy, are we using these energies for supplementing the requirement of the electrical resources which are increasing day by day? It's estimated that nearly 200 million Indian users will be looking for more computers this year. So they'll be buying computers in the form of desktops, notebooks, and other things. So do we have enough power to cater them? So the solution is renewable energy. Why don't we shift over to different sources of other energy which is available? Finally, whenever we buy a product, is it eco-friendly? Does it have an eco label like Energy Star or other labels which are given by the environment protection agencies? So if we buy it, we have to be conscious that these labels are there on our IT products without compromising on this. There are multiple approaches to green IT, and everybody involved in IT has his own share. So for example, the software developers think in terms of algorithmic efficiency. They have to plan algorithms which are productive, which have minimum number of operations, and which actually will produce lesser number of, which actually will make the processor work for a smaller amount of time, and ultimately result in better efficiency and reduce the computing requirements of that program. Then there is terminal servers. Terminal servers are again client server models, but in this case what happens is we use a thin client at the end and we use a big server at the server end, and these thin clients use the computing power of the terminal servers. The advantages are manifold. First of all, these thin clients use all the services that are provided by the terminal servers, whether it is operating system, whether it is applications, or everything is on terminal server. So the amount of power that is used by a thin client is very less, somewhere between 8 to 10 watts of power depending upon the company. Some companies even use 15 watts of power. There is no major hardware in the thin client other than networking equipment, which again uses less power. There are no hard drives in the thin clients. Instead, they boot from the server, and only the booting hardware is there, which again is energy saving. And servers, on the other hand, have to be more powerful. They use a little more energy than a normal PC. But when we have 100 PCs versus 100 thin clients, the savings are many. If you save 1 kilowatt of power, you are basically saving rupees in hundreds. And if you save 1 kilowatt for 100 PCs, and if you have 100 PCs working for 100 days, it means you are actually saving 10,000 kilowatts of power, which means lakhs of rupees in terms of savings. So if we shift from desktops to thin clients, we are not only saving in terms of resources, in terms of energy being consumed by these machines, but at the same time we have benefits in terms of money, because we are saving in terms of spending on those resources. The third one is materials recycling. One more approach to greener IT is that all those computers that become obsolete, let us shift towards the recycling of those materials if they are not being used. If you are not able to find an alternate work for a computer or an IT device, then it has to go for recycling. Virtualization, as I earlier told you, is about using a huge server and using services, using the different types of software services. Logically they are loaded on the server, and physically you feel you are part of that virtualization. And cloud computing is one big example of virtualization, where you pay for what you use. Regarding power management, power supplies, storage, video cards, displays, operating systems are one major concern, which we will be deliberating in our coming slides. Another major approach for greener IT will be, why don't we switch over for video conferencing and telecommuting? why is it necessary to attend meetings if we can do the same with video conferencing as we are doing now? Right now we are part of Green IT. We are doing our conferencing from remote locations and basically saving energy in terms of traveling, in terms of infrastructure, buildings, in terms of air conditioning. We are in our houses, we are doing it, and we are saving lots of resources. And finally, one major IT approach is to do research on greener IT. What are the other advantages that we can take out of our daily work for making a better environment? Regarding the algorithmic efficiency, as I earlier told you that this is the role played by our software programmers who actually develop applications for us. In this, efficiency of an algorithm basically impacts the amount of computer resources needed for any given computing function. See, whenever we talk of an application, computer application, it's basically a program, and program is basically a function which takes some input and converts it into some output. So the function which works on an input to convert it into an output has to be designed efficiently and with minimum number of operations. The minimum the number of operations, lesser will be the energy used by the computer system, and higher the algorithm being developed by the software programmer, better will be the environment and better will be it environment friendly. For example, if we make a search on Google and every search generates some amount of carbon dioxide because the Google servers execute an operation, and that operation in turn generates that carbon dioxide. And if we see how the number of Google searches per day, they are nearly 91 million. And these 91 million generate nearly 18.2 tons, metric tons of carbon dioxide per day, which means 546.6 tons per month, and which means 6,559.2 tons per year. And the emissions of these harmful gases is equivalent to 1170 Audis A4. So Google generates so much of pollution as equivalent to 11,070 Audis. So if we just improve the search query or the program which makes the Google search, we're going to have an impact in the emissions or reduce these emissions, which will finally impact our environment. Also, these algorithms can be developed which can route data to data centers where electricity is less expensive. So all these companies like Google, Yahoo, and other companies, they have their data centers scattered around the globe. So if we have routing algorithms which can route the queries to the nearest centers, definitely the energy will be conserved and the energy consumption will be less. Virtualization is a bigger concept in greener IT. It means we abstract the computer resources on a big server and separate physical and logical resources, where one can have access to many resources, or many can have access to one resource, or many can have access to many resources, where we can have access to many different resources. For example, multiple operating system can be loaded on a virtual servers, where we can have access to Mac OS, where we can have access to Windows, or where we can have access to Linux, being a part of a virtual network. So for this we need special softwares. For example, VMware is there, which is an abstract layer for virtualization. We need to install it and then set up our virtual network. And finally, we are into virtualization, and we can basically reduce and be part of this greener IT. So here I show you that there's a software called VM virtualization layer, and there are multiple operating systems running multiple applications on different hardwares, and at the user end they will feel that they are part of this network and have access to both of them. Cloud computing is a new concept in IT. And the advantages are that we can buy anything which we need. Say, in regards to IT, say it has elastic capacity. You can buy any amount of hard drive space. You are virtualized. It is fully automated. You are paying for what you are using. When you relinquish when you don't need a particular capacity, you can even relinquish that, and it can be used by somebody else. In that case, we relinquish the resources which we don't need. Terminal servers and thin clients. I already told you that terminal servers are servers where which cater those thin clients in terms of resources, computing resources. Users connect to those central servers. All processing is done at the server level. User experiences the operating system which is actually loaded on the server, and OS is shared between users. In this case, what happens is everything is on all the resources are on the server level. So thin clients use lesser energy, but we need high power servers. One more concept of virtualization is desktop virtualization. Most of the software companies follow this desktop virtualization, where they have all their softwares on their servers, and they give this virtualization to their workers and ask them to work from their home, so that they have access to the part of the software which they are developing even from their home. That again is part of the greener IT. How this becomes part of the greener IT? Since this concept work from home actually gives access to the computing resources of a company from the company. So the software developers, they can use any computer at their home just to get connected to the virtualized servers of the company and have access to their resources for the development of the product at their home. So they don't need to commute actually to the company. They don't need they don't need any parking. They don't need any space to work. They don't need any office space except the common space where they can do the meetings. That is how virtualization will help in having software development, and then finally help in greener IT. One more major concern which all of us we need to have, and where we can contribute, is power management. There are two standards, APM and ACPI. These standards basically allow OS to directly control power savings of the hardware. So if a computing device is ACPI, so having an indicator ACPI, so what it means is it is power conscious. So you have a mode in the BIOS where you can set the mode to ACP, and it automatically will take care of your power savings, and it will automatically switch over to save the power. Even, say for example, Intel has launched its processor called Core i7, and this Core i7 has multiple cores, and this Core i7 works on a technology called Turbo Boost. And what happens is this processor consumes some power and some frequency for its multiple cores. So when all the cores are working, it uses all the power as well as the frequency. But when there is a computing function which needs only one core, this Turbo Boost, what it does, it automatically steps down the power to the other cores and instead boosts one of the core to compute the function and increases the frequency as well as supplies the power, so that we actually use only one core and reduce the amount of power being used by the other cores. So that is the advantages of Turbo Boost technology of Core i7. So if we are buying a Core i7 processor, again it's a greener device. So one solution is, whenever we go home, we can power down PCs during night rather than keeping PCs loaded with screensavers. They are actually consuming power. They are not idle. They are working. They are just having a screen with something moving here and there. That's it. But it's working. It's consuming power, and we have higher electrical bills. There are power management features and softwares which can help us manage our power, which will actually reduce the energy consumed and finally reduce in lower efficiency, reduce the life of a product since it's being used more. So power management features will actually help us to, if we know how to control the power functions, will actually be saving money. This is a picture of a auto shutdown manager software which automatically shut down the machine. You can even have remote power management function softwares which you can even manage power of the computers from your home. So to make better utilization of energy being consumed by these devices. Energy 5.0, which is given by the Environment Protection Agency, normally known by the name of EPA, is nearly 90%. Any power device which has this marking is 90% efficient. So if you use a EPA Energy Star 5.0 certified product, it is actually an energy saving device, and the remaining part of the energy is lost as heat. Another part of computer is storage, memory. We use semiconductor memories as well as we use hard drives. Hard drives have those spinning motors which spin the magnetic circular magnetic coated devices, and these platters actually have got magnetic material coated on them, and on this magnetic material we store data. Now these motors consume power whenever we write or read from those devices. Now a newer technology has come which is known as SSDs. So these are solid state devices and they use lesser power than these HDDs, hard disk drives, which actually use those magnetic coated circular platters of magnetic disks, and whereon we store this data. So if we switch over to SSDs then HDDs, it's better. Say for example, if you buy a Mac computer, they have both versions. They have a SSD based Macintosh and they have a hard disk drive Macintosh. So SSD is a little costly, but it's environment friendly. So we as environment friendly people need to prefer SSDs rather than HDDs. Then another way of saving power in this storage is using high capacity flash memories and DRAM based dynamic RAM based drives which use more power. Rather than using DRAM devices, we should prefer high capacity flashes, which actually these are again semiconductor devices. They use lesser power for storage, but they are quick. And the advantage to this is portability. Whenever it is portability, you will have to switch over to flash memory. Depending on use, fast SSD may be a best option. So we should always prefer to go for solid state devices whenever we think of memory. In fact, some of the data center people, they are switching over to SSDs for even data centers, because in data centers the hard drives used is high. They use SANs, storage area networks, for which they have to actually link it with fiber to access the data, and they suggest that why not to use unified networks, where unified network is a concept where in case of servers, what happens is we have to plug a lot of network cables into a computer and then start connecting these servers to the racks. So every network connection consumes some power. So to reduce that power, we need to reduce the network connections. So Cisco has come up with the concept of unified network, where they suggest connecting the server by only one or two unified networks and connecting them to these storage devices, and instead use SSDs as those SANs, and these SANs scatter data requirements for those servers on a high fast fiber. So since SSDs are fast, the network connectivity medium is fiber, and the servers are also fast, so the optimum performance is achieved if you use SSDs instead of using HDDs. One more solution to which can be implemented even in engineering colleges as well as polytechnics, is network printing. In this concept, what happens is, why do we need individual printers on the desktops? Rather, why don't we shift over to using a multifunctional printer, and that too networked, so that whenever any person makes a print command, he has to go to that network printer, punch his security code, and then take out the printout. So what the advantages are: the person will think twice before moving over to network computer, which may be in another room. So he may first think that whether I physically need this printout or not. So probably there are chances that he may not print the material which is not actually very useful to him. So this will actually lead in saving of paper. So we are again becoming energy and paper saving. The next one is that we will not have n number of devices. Instead, if we use a multifunctional printer, the advantage of a multifunctional printer is that we have scanner, we have copier, we have fax, and we have printing all in one. And what happens is, whenever if you have two approaches, either you buy all of these 4 individually, or either you have a network MPF, multifunctional printer. The advantage is you don't have to think of disposal of huge of waste, being it a scanner or a fax or a copier. You simply, when it comes to disposal of this MPF, you have to think of only one device. So you are automatically reducing the amount of material which needs to be disposed when it actually retires. So another advantage with these network printers is, some of the companies are coming up with laser toners which use solid devices for printing. Normally, if you see a laser printer toner, it uses plastic ink inside and then a plastic cartridge with some steel pins and clips. So that's huge amount of waste which comes after we use that toner. Now, instead, what these companies are coming up with are these solid sticks with different colors. You need to insert that solid stick directly into the printer, and when it uses these sticks, the amount of plastic that is being used is very minimum, so the wastage is also minimum. So it is believed that 10% of the waste that is coming out of printers which use those solid sticks, for example, there's a company which uses the solid sticks, it is 90% energy efficient, and the material which the material which comes out for recycling is also minimum. So these are the advantages when we think of printing, using highly efficient printing devices like MPF and network printing. One of the major device which we need to concentrate upon is video cards of our computers. We are playing high-end games which need high graphic power. To get that graphic power, we have to use faster GPUs, which has to perform millions of floating point operations. And when it performs a floating point operation, CPU, it consumes a lot of power. Now the solution is, either we shift over to main board graphics unit, or we can use a shared server where we have a high-end graphics card which can be used by multiple people at different times when they need it. So that can be the solution with respect to video cards in computer systems. And the next one is display of a computer system. Earlier we used to use CRTs, which uses lots of power. Nearly 150 watts of power one CRT monitor would consume. But then LCDs have come up, which uses nearly 4 tubes for displaying a picture. Then energy efficient LCDs have come, which uses only 2. And now we are in a age where LED concepts have come. And that too, there are LEDs which use optical properties to give better resolution and colors, and that too at a lesser power. Nearly 70% power can be conserved by switching over from LCDs to LEDs. So if we switch from first, we have already switched from CRT to LCD. Now we are switching from LCD to LED. It's a energy conservation effort. So, and you are conserving lot of energy, which is approximately 70% if you switch over from CRT to LED, which means nearly 90 to 100 watts of power. The LED will consume just 40, 50, and some even 25 watts of power. Depends upon the type of LEDs that have been used in building those arrays of LED. Another important concern is the operating system which we use in our computers. Windows 7 is an operating system which was not greener. They did not have high-end greener capabilities, but today Windows 8 has come up and they have given energy efficient softwares, applications. For example, let's take this power consumption, remote power consumption. It's become part of Windows 18. Now Windows 8. Windows 8 is because US government has made it mandatory for their companies to think in terms of energy conservation. So they are coming out with operating systems which are by default energy saving. So Linux is energy saving, Macintosh is energy saving. They have inbuilt power management functions which are part of the operating system. When an operating system is shipped, the application of the power management is also part of that package. Another important concern in case of greener IT is telecommuting. Let us shift from physically attending meetings to video conferencing, or at least work from home. This concept has come up in major IT companies. They give access to their computers, to their servers, to people who are working from home, and even permit the employees to work from home. And the advantages are many. One is employee satisfaction. An employee works from home at his ease and availability and gives maximum time that is of use to the company. Another is greenhouse gas reductions. All the emissions because of his traveling, commuting from his home to the office, then looking for the parking space, then the office space he needs, all are overcome. We don't need all this because he's using his home as his office. It actually reduces the overhead costs, which are office spaces, heating or cooling of that space, the lighting that is required for that, office, and the parking space also. So there is significant saving in terms of heat, air conditioning, and light. Other initiatives, other advantages are that the space that is required per employee because of the increasing infrastructure costs again decreases. So any company can start this concept and save in terms even in investing in the real estate, or even making people travel by air to different places to different countries, where they can even save in hoteling, in air ticketing, and the only thing they need is the infrastructure for video conferencing and place for meetings. The important topic in green IT has to be how do we plan to recycle our computer devices, computer IT products. One way is you find a repurpose for your computer. Finding a repurpose means basically if you have a older computer, why don't you can give it to your kids for learning, because they don't need that computing power which maybe actually be used by you. The next one is the alternative is why don't you donate your computer to charities, or why don't you donate your computer to schools or libraries or religious institutions where they can use it for activities where they can get knowledgeable, or to community centers. Finally is, if you don't find any such application, then you have to plan for recycle. Recycling is you have to sell it to a salvage retailer or a municipal recycling plant, where they will actually recycle the product and find a new application where it can be used. Or again sell it to the same companies, which can again use it for the purpose it was being actually made. Say, for example, in case of cartridges, HP buys used cartridges, and then it again uses those cartridges for recycling. So the used cartridges are recycled for sending and are sent and cleaned and refurbished back to the user, and we find again an alternative use. It's basically environment friendly approach. The next one is the used paper can be again be recycled. You can reuse the paper for some other activities. Say, for example, making cardboards, packaging. Paper can be used for that. And then some of the materials can be even used for the batteries which we use, which contain again harmful chemicals, can be recycled and reused for other purposes. So we can again reuse the battery materials and find another applications for it. The big problem in India is disposal. How do we dispose our raw materials? No developing nation is ready to import the e-waste. Instead, they are ready to export their e-waste. In India, by the end of 2015, nearly 200 million people will require new computers, which will again lead to a problem of disposal of nearly 10 to 30 to 50 million tons of e-waste, which means once they buy these computers, they will leave off their older computers, which will nearly tend to be 30 to 50 million tons. And for that, we will have to find space, we'll have to find land where we will fill them, or we'll have to recycle them. When we recycle them, we again generate these gases which are going to be harmful for our workers in those recycling plants. Many of our vendors, because of lack of regulation, are importing e-waste from other countries and selling it to the society for usage, and which leads to lesser lifespan of that product. So normally if I say that a computer has got 5 years or 3 years of lifespan, when you use the e-waste of another country, you have only 1 year lifespan of that product. And our e-wastes are growing faster than if we use newer products, if we use a fresh product, a virgin which is made of a virgin material. And again increasing the high requirement for disposing the e-waste into landfills. So we are not only importing the material, we are actually creating problems for disposing the material into land sites where we can fill them. So requirement for landfills are more. And India has been a country where technology is taken at a very fast speed. Today in India, there must be hardly 20% of our population who don't have an access to a mobile phone, which means that by 2018, all these mobile phones that are being used will turn into e-waste. Technology is changing. Earlier, we used to have we used to have keypads on our mobile phones. Now, most of us are turning to Android-based phones which use those touch screens. But what happened to the older phone with keypad? It has gone into e-waste, and we have to find its disposal. So this is the big problem in India. There's a survey which saw how many of the people, after knowing about greener IT, followed greener IT. And the survey says that 1 in 7 have actually done so. So if any one of us follow the greener approach to IT, it will be out of 7, 1 will start following it today. He will at least start reusing, recycling these materials. If you are using recycled paper or reusing that paper, you are already thinking green. With these words, I thank you for this session. And if you have any questions or queries, you can ask. Any questions?
सर आप माइक डिब्रूगढ़ यूनिवर्सिटी अपना माइक ऑन कर लीजिए सर. Yes sir. Yes sir. Now it's on.
Hello.
Yeah.
Good afternoon, sir. We have gone through your presentation.
Yes.
Maybe some of the things are comprehensible. But actually, don't you feel that for green IT, actually you need policies
True.
from the government?
Sir, as I told you that there is a lack of regulation. In US, what happens is a college, a company cannot buy a product unless it is EPA certified. There is a EPA stands for Environment Protection Agency. This agency certifies a product to say that whether it is energy saving or not, whether it's environment friendly or not. If you want to buy a product from the market, it has to have a EPA certified. Then in these countries, what happens is they even have some software tools to actually see that whether they are efficient or not. For example, in US there's a tool called Abstract. It checks the environment protection of a particular electronic device. If that electronic device is environment safe, then only they certify it, and then these products come in the market. Whereas in India, we have a lack of regulation. We don't have laws to check that whether these companies which are selling products in India are energy safe or energy safe, are they environment friendly, how are they affecting our environment. In India, we are taking it very easy in case of environment, especially when these foreign companies are selling the same products which have been thrown out of those developed countries, and they are selling it in Asian markets. So we need a strong regulation as well as a legislation which will be checking whether these products that are being sold in the Indian market are energy saving as well as environment friendly. And we also as individuals should promote buying those environment friendly devices. Only then we will have a green India.
Maybe I can have a supplementary question to you, sir.
Yeah.
For example, you talk about regulations. I don't talk about policies.
Okay.
For example, say we have institutions.
Okay.
I don't think most of the institutions do not have, for example, this waste disposal policy for electronic equipment. I would say that is e-waste disposal policy.
Okay.
So these kind of things needs to be that means initiated at the institutional level. Maybe at our universities, maybe other institutions which are major users of that means this electronic equipment, and where that means because of changing technology and obsolescence, things have to be changed very rapidly, which leads to creation of a lot of this e-waste.
Sir, you are absolutely right. In this, we as individuals, we as part of organizations, have to have a policy where we can think of reusing the IT products, where we plan to refurbish those IT products for alternative use, and the policy has to be part of the organization. Not only at the individual level. Once we get aware about greener IT, we have to do something. We cannot take it or postpone this problem. We have to be very conscious, and we have to find a solution. We have to be part of the policy making. And as you, so for example, some of the audience which are connected today are principals, are policy makers, are directors, are registrars of universities. They are the policy makers of these institutions. They can think about those greener approaches, greener IT approaches. They can plan for if there is some of the devices which they think of converting into e-waste, rather send it to schools which need, or they can charity it where they can be used, and they can even suggest suggest their IT administrators of their institutions to plan a proper usage of energy which is being pumped into those IT devices. So there has to be a policy on the college level as well as the individual level.
There is a question from Government Polytechnic, Ambala City, sir. Can
Yes,
you hear
sir.
me?
Hello.
Yeah.
There's a question from
How many
comment.
implement the recycling or in disposing these items? So
Can,
there are no fixed agents that has been
Sir,
determined.
can you sir wait for just 1 minute? There is a question from another center. Yes, Ambala.
Yeah, my question is, there was a Kyoto Treaty regarding the carbon emission points, and every nation, whosoever emits the greenhouse gases, has to go for the carbon points, and depending on the greenhouse emissions, CO2 it emits, they have to take back the carbon or purchase the carbon points from the other developed or the developing nations.
okay.
How far that has been materialized on the international ground?
Uh, this regarding this carbon dioxide emissions, definitely they have to find a solution to that. And as far as IT products, we don't have such carbon points where we can actually measure the amount of carbon dioxide coming out of. There are devices which can measure, but we don't have solution to. Either you have to dispose it, or either you have to find an alternative use. There's no such way of replacing, because if there are the major parts of a computer system which generate carbon dioxide are the electronic semiconductor chips which are being used, which may be a processor, which may be some memory chips, or which may be the chips on the hard drives which generate those CO2, or the power supplies. So as such, there is no checkpoint where we can get these IT products checked and then find an alternative, then suggest to change or to replace those products. As such, there is no such carbon checkpoint.
Like my question was, there was a Kyoto Treaty, and with the carbon credit points were there, depending upon the how far the emissions, carbon dioxide emissions are there, right? Not depending upon the type of the industry, depending upon the type of the these electronic devices, and these developing nations are used at the dumping ground, and for that there was a Kyoto Treaty that each one has to go for those carbon credit points depending upon what emissions, what pollutions he is creating. No, when we go for the this green IT, there are certain these developing nations are used at the dumping grounds. Whatever the technology is obsolete in the developed nations, they are dumped in the developing nations. For that, under the Kyoto Treaty, they had decided that they had to buy some carbon credit points for that, depending upon the type of the emissions they go for, and they have to reduce it by buying the carbon credit points. How far that has been materialized on the international ground? This was my question.
Yeah. See, regarding this carbon dumping or the product dumping in the landfills, there is a treaty wherein even India is part, and we have to have some credits for dumping our e-waste. But the problem is different in our case. We are even importing we are importing our electronics, electronic device and IT products, which we are dumping in our landfills, for which we don't actually have those credit points for which we require for dumping those. So on international level, these countries, they are aware about the consequences that is it's creating for their environment, but they are not bothered about the other countries, underdeveloped countries or so-called underdeveloped countries, where they think they can dump their e-waste by just exporting the products and even improving our credits. But ultimately, the material gets dumped in our landfills and becomes a hazardous waste for our people.
Right, sir. Thank you very much. Thank you very much.
Anybody else who has any question?
Hello.
Yeah.
Hello.
Yes.
Hello. I wanted to ask how do you implement the reverse logistics of disposing the items in India, since the agents or the stages are not defined properly here. So how do we implement here in India disposing of e-items?
Okay. See, the first one is why when we go for buying those devices, is there any way of finding a larger lifespan of a product? Say for example, if you want to buy a mobile phone today, it is suggestive because of the environmental concern that you buy a product which has probably a longer life cycle that will actually generate your e-waste after a lot of time. That means basically we want to reduce the amount of electronic waste. Another thing is then disposing. Other than once it comes to disposal, we suggest that you go for the alternative use. You try to find an alternative use for your product. It is, if it is working, you can either donate it. That is one way of disposing it. Another is you send it for recycling. If you send it for recycling, some of the material of that computer can be used for manufacturing other devices. And the third one is you can even reuse your own computer. Say for example, if let us say that
I just also, sorry, I want to interrupt here. Like for recycling, you say you recycle the parts. From who will be the agents to take up these parts in that particular reverse logistics or in the reverse supply chain?
no,
Who would be the agent to take up this?
There are salvage retailers. There are salvage retailers who buy those used computers and then they sell it to the recycling plant. And even there is a reverse value chain. For example, even company buys some of the material like cartridges, like toners, used toners to make new toners.
So it is properly defined in all the parts of India, or it is there intermittently in some places?
No. It is, see, most of us are going or thinking green just from last few 10 to 15 years. We are thinking in terms of greener technology. We are becoming more and more conscious about the e-waste and that is coming, that's either being imported or generated by us. So now we are being more conscious and we are creating this awareness to just find the solution to this problem. And if we find the solution, we'll be more environment friendly in the coming years. So we are taking steps. If we take steps now, the benefits we are going to reap in the future. Our next generations will be reaping the futures of and getting away with this hazard. Any other question?
Sir, I think we can have a break.
Okay, we'll close this session for the time and we'll have a lunch break.